Hello, folks. Good morning. How is it going so far? Good. How many of you were in Priya's session this morning on the headliner stage? Priya herself was there. Okay, a few of you were there. Okay, good. So this is really a complimentary section. It really builds on what she introduced. But for the sake of those who are not there, I'll have a couple of introductory slides. Which sort of sets the stage and then takes us into industry examples of the concept of AI governance. Yeah, and given this is a small audience, happy to take questions as we go along, or if you want to hold your questions to the end, I'm okay either way. Okay. All right. Okay, let's get started. Priya introduced a few challenges that we face in operationalizing AI. I'll just summarize it just to catch us up. One of them is, as companies look to deploy AI into their business processes, into their decision making, there is a constant challenge around managing risk, both financial risk and reputational risk. She shared with you guys, whoever was in that session, you probably saw some of those news clippings of companies making the news for the wrong reasons because AI was used in an incorrect way. It was biased, it was unexplainable, it was a black box that nobody could understand. So just this challenge about risk management when it comes to operationalizing AI, that's one. The second topic that we had talked about was a growing set of regulations. She talked about 2 regulations every year now. The latest one is the New York State hiring restriction, the hiring regulation. If you look at what is happening with the European Union, with the US government, and if you look at the policies and the half policies that have been put out there, you have to pay attention because otherwise you get into a state where you have built a lot of things, your data science teams are cranking out things, but you cannot go into production because you're not compliant with these regulations. And then there is this aspect of the actual business itself, the business bottom line itself being affected because your AI quality is not as where it should be. So all of these are challenges. We talked about, you introduced these things, concepts. I want to talk for a few minutes about aspects of trustworthiness in the context of this. When we hear the term responsible AI or ethical AI or trustworthy AI, how many of you are dealing with that in this space now? Okay, half the room. Bias and fairness, everyone gets it, right? Explainability, everyone gets it. Let me ask you, how do you actually look at bias in your model when the sensitive aspects, the attributes, maybe gender or ethnicity or age, is not even part of the model? How do you deal with that? Sorry? No, you're not predicting gender, right? You're saying your data set is not incorporating sensitive attributes like age, gender, and ethnicity because your company's policy prohibits you from doing that. But you still want to make sure, if you're building a credit risk model, that when you make those credit risk decisions, approval, rejection, etc., that it is not biased women versus men, or a certain age range versus another age range, or one ethnicity versus another. Some interesting challenges when you start looking at indirect bias, proxy bias, and then mitigation when that is the case. Right? So while it's very easy to get your head around, okay, I get bias and fairness, the actual challenges around this space are huge. Sometimes that sensitive aspect, the demographic information, is not even available at the time of model scoring. It can be available only much later, 24 hours later, a week later. What kind of guardrails do you put in place? Now, explainability, everyone gets explainability. Okay. John applied for credit, John was denied, John wants to know why he was denied. Okay, that is a local explanation. But how do you understand global explainability? How is the model behaving in aggregate? How do you understand contrastive explanations? If Priya and I both applied, she was given her loan, I was denied, At what point would I have been given the loan? How much should I look like her? Stuff. She looks way better than me. How much should I look like her for my loan application to be accepted? So the notion of contrastive explanations is, what is the range of values in your data set at which point the full range at which the outcome would have been different, or the outcome would have stayed the same. Unless you put these things into practice, these challenges cannot be addressed. Robustness. Anyone who has built a model knows that there are fine boundary lines which flip the answer from from true and false, from this range to that range. There are fine boundary lines, especially if you're doing most of the standard fitting mechanisms. Something that is happening quite a bit out there is people who figure out what those boundary lines are, they do that by brute force today, and then feed in data that is very close to that boundary line so that the decision the model makes is in their favor, although in aggregate they should not have been given a positive outcome. So how do you understand robustness of your model? I'm presenting a set of challenges for you to think through. These are all new areas, and you have to start thinking about this in order for you to be compliant with the regulation, in order for you to protect against the reputational risk we introduced, in order for you to be able to operationalize AI in a way that the business is confident about. For anyone who claims they have solved this, they're lying. This area is so nascent and so fast evolving on a weekly, monthly basis. But what I would encourage in this session, I'll share the examples, the industry examples, is to start thinking about these as you build out and deploy models in production. Because what you don't want is to be caught without guardrails after you've deployed or when you're going through the deployment phase. Okay. We talked about IBM's approach to this, which is threefold. One is, question?
Just wanted to clarify earlier by predicting them and CFPG like for finance, I know that they use like a prediction methodology based on like name of the person and their zip code and stuff, then append like race ethnicity onto the data set.
Yeah.
And then from that, even though you can't have race ethnicity in the model itself, you can use the appended race to see in training of the model, and then you can remove it. So it's not actually in the model.
Yeah, so very good observation, very good observation. There are various mechanisms to indirectly understand sensitive aspects like age, gender, ethnicity. Zip code is probably the most well understood proxy, north of the train line and south of the train line, right? So we know this, right? And if you look at socioeconomic data sets that are actually curated and put out there by the various companies, they actually get to block level detail in proxies for ethnicity, proxies for economic status, proxies for educational level. Of course, it'll never be at the individual level because you're not allowed to do that, but you get even block level information, which has to be brought into the equation. Now, if you have that information available offline, there are mechanisms which say the model scoring has happened, but at least how did the model behave in terms of fairness at that individual level? And then what is the mitigation here? If the model scoring has already happened, but you found out that it was not fair, the mitigation has to follow a series of steps, right? So you have to put that into the workflow. So we talked about three different things here. Lifecycle management, one of the most basic observations here is you cannot look at this after the fact. After you have built your model, after you have deployed, you can't just come back and say, yeah, well, look at fairness now, or I'll look at explainability now. You have to look at it through each stage of the life cycle. Is there bias in the data to begin with? The algorithm that you select, XGBoost, LightGBM, whatever, right? Which algorithm is going to precipitate that bias the most? And then when you go through the model validation step, what is the validation you are going to do? What policies are you going to comply with? What regulation are you looking to satisfy as part of your model validation and risk management step? And I say you, that's an aggregate you. It may not be the data scientist. It may be the validation team. It may be the risk management team. But if you have not thought about this, you're going to come into a stage where, okay, got a great model, AUC is awesome, fails a fairness test. Doesn't go through a model validation, doesn't go through risk management, and will not get deployed. Then it's back and forth with the model validation team, data science team, weeks of back and forth, trying to get all this data to the risk management team. So the message here is think of this through each stage of the life cycle, starting with exploring data, algorithm selection, model validation, and once the model has gone into production, how do you monitor this? The second part is, as much as possible, automate aspects of this. Because if you have the data science team trying to run after every single piece of this, you will never be able to scale. So fact collection, that second part here, automating fact collection. How many of you here actually write Python code? Oh, just 2 people. Okay. So maybe you work with teams that write Python code. The data scientist is sitting there and writing Python code. How are you going to collect facts about what he is doing without intervening too much into his or her way of life? What algorithm was used? What hypertuning parameters were used? What tweaks were done with the algorithm, with the model fit? How do you capture all the facts about building the model in an automated way? Then when the model is being tested, how do you collect facts about that? And make this all part of your fact sheet so that the risk management team can look at it and understand how this was built, right? So automating as much as possible so you manage risk better. And the compliance aspect with the regulations. European Union has come out with the draft EU regulations, which we believe will be even more significant than GDPR in terms of impact. 6% of your company's global revenue is at stake if you don't comply. 6% of your company's global revenue is at stake if you don't comply. You don't want to be caught in a place where, I did not comply with this regulation. But if you have your data science team starting to think about, oh my goodness, what does the EU regulation mean for my model versus the New York state law versus the US law, that is going to slow everybody down. So you need mechanisms which will map the regulatory requirements to the model lifecycle stages. Right? So these are the 3 pieces of the puzzle that need to come together. I'm going to take you through 3 examples. This is one of the larger retail companies in the world. They use AI for hiring. Now, the reason I picked this, although it's retail, hiring is something that applies across industries, right? Thousands of people apply for jobs. The way they decide who to hire is they look at the resume, they look at the details of the applicant, and they use a machine learning model to score the employment eligibility of the applicant. They do a rank list, they send it off to the prospective hiring manager. The company at the topmost level said, well, we have a social responsibility agenda, so we want to make sure that when we do hiring, it is not biased in terms of women versus men, or one ethnicity versus another, or age range, or they had a bunch of other things like disabled person, or things like that. Now, none of those attributes are in the data set. Priya gave a really good example earlier. An attribute that we came across, willing to work night shift or not. What do you think that's a proxy for? Gender. Now, it will never be perfect. So now the business decision as to whether that variable, that aspect is a proxy and that needs, what is the correlation between that and gender, needs to be assessed at design time. during the model build phase, as you look at the data set. Then you need the guardrail in place once the model is validated and goes into production. Now, for them, there are a bunch of other requirements, right? It has to fit in with existing environments. They are a big Azure shop. Everything happens on Azure with their homegrown development stack. Model building, deployment, monitoring, everything happens in Azure. They're not going to change that. So whatever guardrails we put in place needs to fit into that Azure environment. I'll come and show you the architecture view of how this is solved. But I want to present first 3 examples from 3 different industries. Healthcare. I think we have someone from healthcare here. Equitable healthcare is one of the most, it's a buzzword these days, equitable healthcare. This is working with one of the blues, one of the blue shields. And they have an advocacy program which says, I want to understand out of my member population who is at most risk to have an adverse condition in the next 3 months. And I want to proactively intervene into their lives and prevent that ER visit from happening. Obviously, everyone benefits if you can do that, right? The person benefits, the company benefits because of the lower costs. They can better plan for hospitalization, all of that stuff. But the line of business owner said something very interesting, and I still remember this conversation from a year ago. John, equitable care is important for us, and I'm going to tell you a story. This story has stuck with me, and I'm going to share the story with you. She said, John, imagine 2 women in their mid-50s. One is gainfully employed, the other is not. The first woman has the luxury to take off from work and go see her PCP on a regular basis and do her preventive checks. The second woman is struggling to make ends meet. She doesn't have the luxury to take off from work. She's not going to go see her PCP. Guess who is cutting the claims records? The first one. Guess what that historical data has? That historical data set is biased to begin with. You go build a model against that, you send an algorithm loose, or even if you do the best algorithm search and do the fit and everything, that model is biased to begin with. So the first order of business is to understand bias in the data. Now, how do you fix if you do find bias in the data? At least you have understood that what is going on, right? Sometimes it is difficult to fix because it's a process change. But the way they approach this is to use synthetic data that balances out the bias that exists in the historical data and evens it out so the algorithm is learning in a better way. For them, the life cycle starts with that. It starts before data exploration starts with the line of business saying, yes, these are the things that are important for us. This is what is acceptable. This is not acceptable. These are the disparate impact metrics we care about. This is the statistical parity metrics we care about. This is the mitigation we need post hoc. That has to be decided upfront. Then you go look at the data. If you have to use synthetic data to complement what is actually in the historical data set, you have to do that. Then you go through the algorithm selection phase. Then you got to validate this. So for them, it is claims data, electronic medical records data, EMR data, and socio-economic data from third parties at the block level, combined to be the data set that you train on. And you have to understand what is going on. Now, explainability is an interesting thing. You say, okay, John Smith is at risk of an ER visit related to diabetes over the next 3 months. John Smith is a bad example. Jose Castro is at risk. I'm very consciously selecting that name. They've got a whole community health advocacy program, right? Now, if they are sending someone to Jose's community to talk to them, you may want to have a Spanish-speaking person. You may want someone who is better able to relate to the member community that they are interacting with. Without explainability, you will not know what are the factors that is making Jose a high risk person. And once you understand that, you can say these are the best intervention mechanisms and these are the best people from the community health advocacy program that can talk to you. Question? 5 minutes, okay. Financial industry. A very large financial client. For them, it was all about going through the audit process. The audit process was very time consuming. I talked about fact collection earlier. See, the model risk management team is asking for proof for everything that was done. Wait, what data was used? What parameters were considered? What algorithms were used? What alternative scenarios did you consider? The data scientist may do a lot of those things manually on his desktop, whether you're using Data Robot or Azure Stack or SageMaker, doesn't matter. You're doing all of this, but what is the proof you're going to bring to the audit and compliance teams? So fact collection becomes important regardless of what tool was used to build and deploy the model. What they ended up doing was building an AI governance hub for the chief data officer to look at. So they have got 4 or 5 different lines of business: retail banking, investment banking, et cetera, models being built in each of these different lines of businesses, different tools being used, everything from MATLAB and SAS to Data Robot to homegrown tools to cloud-based, hyperscaler-based tools. Regardless of what tool is used by each line of business and team, you need the facts to be collected. They all need to be governed by the same workflow. This is the stage gate for model validation. This is the stage gate for an approval for model deployment. This is a stage gate for what will happen every week after the model goes into production. So you have a consistent workflow. You have an enterprise governance hub that allows the C-levels to look at what's going on across the company. All 3 of these examples, the healthcare one with equitable care, the hiring one, and the audit, making the audit process easy for financial sector, all follow this basic construct of architecture. I don't have any IBM products listed here. This is meant to be a conceptual view. Happy to talk to you about what is behind each of these blocks. If you look at the stages of the life cycle and what is needed, that box which says process, approvals, attestations, risk assessment, management, and reporting, it's a bunch of different things in there. Think of what is needed. What is the workflow through each stage of the life cycle? Everything from talking to the line of business, to data exploration, to model building, to model testing, unit testing, to validation, to deployment, to ongoing monitoring. What is that workflow? What are the stage gates? What are the artifacts that need to be produced at each stage gate so that you are allowed to progress to the next step? Look at the top one, fact collection. Through each stage, as the data scientist writes Python code, can I collect facts? As the model validation team does the model validation risk management, can I collect facts? As the model runs in production, can I collect facts about that? And make this all available in an automated way for risk management and compliance officers to act against. At the bottom, you have lineage and policies. What data is being used? Who touched that data? Who modified that data? Was synthetic data used? As was the example for healthcare. How do you understand the impact of synthetic data versus the actual historical data? And how do you represent that when you're reporting against it? Lineage, rules and policies. Who is allowed access to the data? So sensitive data, for example, you may be obfuscating some of that. You may be redacting that. Does that rule or policy stay in effect through the life cycle of building and deploying and testing? Right? So this is the architecture of what is needed from an AI governance perspective. A little bit of zoom in. Now it's got some product names in there. I won't go into that now, but workflow, a feature store becomes important. The concept of a workflow management system becomes important. The concept of rules and policies being defined for each stage becomes important. Guardrails for monitoring bias, mitigating bias, generating explanations, monitoring drift, both data drift and accuracy drift becomes important. All of this fits into this picture. And one very important thing I want to call out before I run out of time here is this works no matter what development tool you're using. That's huge, guys. You can continue to use SageMaker or Data Robot or whatever. We would love you if you use IBM tools, but regardless of what tool or tool sets that you use, you can provide this governance framework. It fits in your existing environment. Okay? Happy to talk more. I think I'm out of time. Questions? I think we can take maybe a minute or so. Any questions or comments? And then we can have detailed discussions outside. Does this make sense, what you listen to? Yeah? Okay.
Sayed, I'm curious, how do you address the bias that is, that exists in the data? And it's because, say, sometimes there are stigmata or society stigma issues, right? So if you try to look for the certain segment in the population that may violate their privacy, even though your intentions are positive, great, to better represent them, but that could infringe their privacy.
Yeah. So I understand totally the privacy concern. Before you get to individual level, before you start looking at individual records of Jose versus a John, you have to look at this holistically. Okay? So as an example, the healthcare example I gave, if you have block group information, block level information, zip codes, okay? You kind of know, okay, this is a predominantly African American population, or this is a predominantly Hispanic population. I'm using this as examples only, right? Just examples. You can have a whole bunch of variety of permutations and combinations around this. And then you start looking at the claims records from that block address. What is that is present in the historical data? The first analysis tells you whether that data is biased to begin with. Do you even have enough data from that block group? If you do, what kind of data do you have compared to a different block group or a zip code? You can put that and compare. So you have about a dozen different metrics for fairness assessment in data. So simple ones that you can get your head around are things like disparate impact, right? So you can say, what is the ratio of positive outcomes for the minority group versus the ratio of positive outcomes for the majority group? It's a very simple metric to get into. There's about a dozen different metrics. So you can look at that and say, okay, the data itself has got a problem. And then the mitigation of that problem could be multifold. One could be sampling, a balanced sampling from different types of data. One could be generation using synthetic data to offset what is lacking in a certain portion of the data. Some of them cannot be addressed with this. And then at that point, it's a business decision which says, okay, this is only as far as we can get in terms of data augmentation with synthetic data or whatever other mechanisms you use. But this is a risk we are taking, and we are very consciously making it visible to all the stakeholders that this is the set of data that is being used. These are the bias metrics that exist in the data. At least it's documented, at the very least. Okay? Not an easy solution, but the point is you have to start with that first stage of understanding what is in the data. Okay. Any other questions? Sorry, out of time? Okay, out of time. Happy to talk more offline. Hopefully this was of some interest. At least it will pique your interest enough for you to go look into this. Go look at IBM and AI governance. What do we do in this space? Everything from workflow to fact collection to bias and explainability handling to robustness and regulatory compliance. Thank you very much for your time.